So now let us see some more problems on ideal gas equation. So if a 2-liter flask of nitrogen at 20 degrees centigrade and 70 centimeter pressure is connected with a 3-liter another flask of oxygen at the same temperature and 100 centimeter mercury pressure. So what will be the final pressure after the gases has thoroughly mixed at the same temperature as before? Also report mole percent of each gas. So we have given here two questions. One is the final pressure and one is the mole pressure percentage of each gas. So in this flask, so we can see here the question is, if there are two flasks, we can take here two flasks. One is 20 degrees centigrade, then 2 liter, and here pressure is given 70 centimeter, and in this case this is your, so one is your nitrogen, this is your nitrogen, and this is your oxygen. So an oxygen volume is 3 liter and pressure is given here, that is 100 centimeters. So like we can write here, so here nitrogen is how much? PB by RT. So PB is nothing given here, 70 centimeter. So divide by 76 centimeter, and volume is 2, and here 0.0821 multiplied by 293. So you will get here 7.658 into 10 power minus 2 moles. Similarly, moles of oxygen we can find. So again 70. So we can write it 100 by 76, and again we can see 3 divided by 0.0821. Okay, and this is this temperature down. Okay, so this is 1 by 293. So again you can solve it, 6.41 into 10 to power minus 2. Okay, now what is the final pressure? So final pressure will be V. Final pressure will be what? This is, and moles of initial pressure, that is N2 plus O2. Okay, so total moles. So this is multiplied by R into T. So pressure is given P final, and volume is 5 liter, and moles is, so if you add it, so 7.658 plus 16.41 into 10 power minus 2. Okay, and I can multiply by 0.0821 into 293. They are asking 293. So here pressure will be, that is 1.158 atm. So this is the pressure will be, final pressure will be this much. Okay, now they are asking mole percent of nitrogen. Mole percent of nitrogen. Mole percent of nitrogen will be 7.658. This is the mole of nitrogen, and percentage weight will be this much. So 7.658 plus 16.41 into 10 to the power minus 2, and again multiplied by 100. If we solve it, so we will get here 31.8%, and again mole percent of oxygen will be how much? To 100 minus 31.1, so we will get here 68.2 mole percent. This is the mole percent of oxygen and nitrogen. So we will see second problem. 2 gram of gas A introduced in an evacuated flask, so kept at temperature this 25 degrees centigrade. The pressure is found to be 1 atmosphere. If the 3 gram of another gas B are added to the same flask we are adding another gas, the total pressure becomes 1.5 atmospheric pressure. So assuming ideal gas behavior, calculate A, first ratio of the molar molecular weight of A and B, and second the volume of the vessel if A is oxygen. So we can see here, first is total pressure is how much? So total pressure is PA plus PB. This we can see that 1 by 5 plus 1 plus pressure of B. The pressure of B becomes 0.5 atm. So we know the pressure of B. Now case A, so we can take for gas A. For gas A, we need to find out what is the molecular mass. So we use the formula PV equal to nRT. So in this we will find the molecular weight of A. So first write partial pressure of A into V will be moles by molar mass of A. So this is the moles into R into T. And for gas B, you take gas B, so this will be your B into V, and molar mass is, weight is 3 gram divided by molar mass of B into R into T. So since pressure is same in each cases, okay, before adding, So we'll get here ratio will be, so M is here, ratio will be your MA by MB. This will comes about 1/3. So here we got the ratio. Okay. Now question is, second question, B part. If gas A is oxygen, if gas A is oxygen, okay, so if gas A is oxygen, okay, so what is the volume of the container? So volume of the container will be, this is your moles, okay, moles into 0.0821. So R is given, temperature will be 298 and divide by 1. Okay, the total pressure will be that volume of the vessel if A is oxygen. So this is the volume of the vessel if A is oxygen. So answer will be 1.529 liters. So this is our basically answers. So here I have two questions there. The density of the mixture of oxygen and nitrogen at NTP is 1.3 gram per liter. Okay, so calculate the partial pressure of oxygen. Okay, so how to calculate? So density given, two gases. So let oxygen is N mole, and here nitrogen is N1 mole. This is your N2 mole. The two moles are given, nitrogen and this one. So average molecular mass. So average molecular mass of oxygen plus nitrogen, it will be how much? So you can multiply by molar mass of oxygen into N1 moles plus here molar mass of nitrogen into N2 moles and divide by N1 plus N2. Okay, so this is the average molecular mass. So this is the one part. Second part, we can use PV equal to P into V equal to N into RT. So N is the total moles of the gas. So here volume they are given. So again N is equal to weight by molar mass of the mixture, we can say, into R into T. So this you can put here molar mass of the mixture. So P by W by RT. So W by RT by PV. So W is given W by V. So W by V is W by V will be your density into R into T. So this is just nothing but the density of gas. We can say density. So density is given how much? So this is your 1.3 and R is given 0.0821 and multiplied by this is your 273 and divide by 1. So if you solve it, you will get 29.137. So this is second equation. So we can see here both these are average molecular mass, so we can equate. So on equating we will get N2 ratio. So we can write here 32 N1 plus 28 N2 divided by N1 plus N2, and here will be over 29.137. So here we will get N1 by N1 plus N2, so ratio will be 0.28. So this ratio will get from here. So again molecular mass of oxygen will be how much? 0.28. So we will get answer. This is the mole fraction. This is the mole fraction of oxygen is 0.2. Okay, now partial pressure of oxygen. So we can see here. So partial pressure of oxygen is how much? So mole fraction of O2 into total pressure. So mole fraction is 0.28 and total pressure is 1. So this you will get here 0.28 atm. So 0.28 is your second answer. So we will get two answers. This answer, this answer. Now second question is, if you see here, second part of the question. Now second question. A flask of capacity 1 liter containing ammonia at 1 atmosphere and 25 degrees centigrade. A spark is passed through until all the ammonia is decomposed to nitrogen and hydrogen. So calculate the pressure of the gas left at 25 degrees centigrade. So 1 liter contains ammonia this much, and this is the atmospheric pressure temperature. So on passing, this is composed to two gases, nitrogen and hydrogen. Okay, so we can write here an equation of ammonia. So ammonia will decompose like this one. So NH3 will be converted into N2 plus H2. Okay, so balance it 2E here and 3 hydrogen. So this is the balanced. So moles of ammonia will be how much? The moles of ammonia will be PB by RT. So PV given 1 liter 1 atmospheric pressure, and here 0.0821 multiplied by 298. So on solving we will get here 4.08 into 10 to the power minus 2. Okay, now it is given pressure is directly proportional to number of moles when temperature and volume are same. This we know the from the gas laws. So when temperature and volume are both are same. Okay, so we can see here pressure of initial moles divided by pressure of second pressure after reaction. This becomes N1 plus N2. So N1 means mole will be different and hydrogen will be different. So we can write here 1 by P2. This is nothing but the P2. This is a P1. So 1 by P2 is equal to 2 by 4. So why 2 by 4? So this is the pressure of ammonia. Ammonia is 2 moles and P2. So after it becomes 4 moles. So this is the 3 plus 1 4. This is your nitrogen plus 3 moles of hydrogen. This is the only for the ammonia. Okay, so ammonia is 2, 4. This becomes 1 by 2 half. Okay, this is our first part. Now second part is the pressure of gas left after this one. So this is the pressure. So P2 is equal to 2 atmospheric pressure. So this is after reaction. Now second part is the moles of nitrogen hydrogen formed. So moles of nitrogen formed will be how much? So half mole. Why half mole? Because nitrogen is 1 mole. This is the half mole. So nitrogen is 1 mole. So 1 into mole of ammonia. So this is half into 4.08 7 into 10 power minus 2. So this you will get answer 2.0435 into 10 power minus 2. And moles of hydrogen formed. So moles of hydrogen formed will be 3 by 2 moles. So 3 is the hydrogen and 2 is the total moles. Means this is moles of ammonia. So this is multiplied by again moles of ammonia. Okay, so if you multiply it 3 by 2, so moles of ammonia is already found out that this much is moles of ammonia. So we can see 3 by 2 into moles of ammonia is 4.08 into 10 to the power minus 2. So we will solve 6.1305 into 10 to the power minus 2. This is our basically answer. So again 1 liter of oxygen and 1 liter of hydrogen are taken in a vessel of 2 liters capacity at NTP. So the gases are made to combine to water. So calculate the weight of water and if it moles are formed. So we have to find weight of the water, moles of the gas. So how to find out? So here we'll see 2 things are there. So first we'll find this one. H2 plus O2, it will give you what? Water. Okay, so initial volume is how much? This is your 1 volume, this is 1 volume, this will give 0. And here after reaction it becomes 0 and it becomes 0.5 and it becomes 1. So by volume, so volume of this is 1 mole, so 1 liter, all these are in liter. So this is initial volume, this is the volume after reaction. And total of volume in the flask is how much? 2 liter. Okay, so we can write here mole of water formed. Mole of water formed, that is equal to, that is nothing but the mole of hydrogen used. So this is water formed, nothing but the whole hydrogen converted to water. PV by RT. So P is 1 into 1 and R is 0.0821 and temperature is 273. So on solving you will get here 4.46 into 10 power minus 2 mole. So weight will be how much? So weight will be your 4.46 into 10 to the power minus 2 and again you multiply it by 18. So you will get total gram, that is 8.03 into 10 to the power minus 1 gram. So this is our answer, first answer. Now second is the amount of gas left in the vessel. So we can see here moles of oxygen left. So how much oxygen left? If you see here, so moles of oxygen was 0.5 moles left. Okay, so we can see here again PB by RT. So pressure was given 1 and moles of oxygen 0.5. So this is the volume of oxygen left, and divide by 0.821 and multiplied by 273. So if you solve it, 2.23 into 10 power minus 2 mole. So total weight will be your, so weight of oxygen left. Okay, so here how much is there? So this will be your again 2.23 into 10 power minus 2 into 32. So this is the weight, 0.713 gram. Okay, now third part is total pressure if vessel is heated at 100 centigrade. So total pressure will be at 100 degree centigrade. So H2O is converted to steam. It will be converted to steam. So total moles of water will be how much? So mole of water and mole of oxygen, because it's converted to gas, this will remain in the gas also. The total moles of water, so already we have seen it, it is 4.46 into 10 power minus 2 and plus 2.23 into 10 power minus 2. Previously we have seen this one and previously water also. So if you solve it, you will get here 6.69 into 10 power minus 2. Okay, so total will be, if you solving, so pressure total, so pressure total will be 6.69, okay, into 10 power minus 2 into 0.0821 into 373. Okay, and divide by volume is how much? So volume is given 2. So this is the total pressure. So again, if you solve it, it becomes 2.23 into 10 to power. No, sorry, on solving this one, you will get here 1.02 atmospheric pressure. This is the total pressure. Number C. Again D. So under D is volume of oxygen used in formation of water. Okay, formation of water, so that is nothing but the half liter. Okay, this is 0.5 already given, is given here. Okay, now moles of oxygen used at NTP, so this is nothing but the 0.5 by 22.4 liters. So you will get here 2.23 into 10 to the power minus 2 moles. Okay, so half liter will get this much moles. Next is an evacuated glass vessel weighs 50 grams when empty, 148 grams when filled with a liquid of density 0.98 gram per ml, and 50.5 gram when filled with ideal gas 760 millimeter of mercury and 300 Kelvin. So determine the molecular weight of mass. So weight of liquid, we can say weight of liquid is how much? 148 minus 50. So this will give you 98 gram. And volume of liquid is how much? So volume liquid is volume of vessel. So volume of vessel will be 98 divided by 0.98. This is become density and this is the volume of mass. If we solve it, it will become 100 ml. So we know the volume of vessel. Now weight of gas. So if you see weight of gas, now this is what is the weight of gas. The weight of gas will be total volume with gas minus 50. So, okay, so this is the total volume, this is the total, and this is the gas, weight of gas. Okay, weight of gas. So this will get here 0.5 gram. This is the weight of gas. Now we know the molar mass of the gas. We don't know. So again use the formula PV equal to N into R into T. So this implies that 760 is 760. So pressure is given. So again volume is given your 100 ml. Already we find out this 100 ml is the volume. Again weight is 0.5 gram and molar mass into R into, so R is 0.0821 and multiplied by 300. So here you will get molar mass will be 123.15 grams. So this is our answer. Now next is an underwater bubble with a radius of 0.5 centimeter at the bottom of the tank, where the temperature is 5 degrees centigrade. Pressure is 3 atmospheric pressure. Rises to the surface where temperature is 25 degrees centigrade. So pressure and pressure is 1 atmosphere. So what will be the radius of the bubble when it reaches to the surface? So here we have to note it down. Moles of air contained in bubble, so at bottom of tank as well as on the surface is same. So we have to take this thing, each surface is same. So we have to take this thing. So mass of the air at bottom and surface both are same. So we can see moles will be same. So here moles will be also moles of the air. In this case both are same. So we can use here P1 V1 by R1 by T1. So moles are same. This is equal to P2 V2 by R. R is the same only. So T2 will change. So we can write here, this is the bottom and this is the surface. Okay, so we can use the formula. So we can use 3 into 4 by, volume is 4 by 3 pi. So here volume is 0.5 whole cube and divided by R. R is the same. So 278. Now here pressure is 1 and volume is 4 by 3 pi. R we don't know and we have to find out here 298. Okay, so this will be your 3 by 278 into 0.5 whole cube, and this is your R cube by 298 on solving. So we get here R equal to 0.74 centimeters. This is the radius of the bubble on the surface.